What we try to do is indeed this is one of the problems we try to solve by using our expertise. There is over 40,000 fatal traffic accidents in EU, 1.7 million injuries. That means 150,000 people every year that stay disabled for the rest of their life. In Belgium, we have over 850 people that die in traffic. As you can see, falling asleep is a big thing in this problem. There is about 20% of the accidents that is related to people who fall asleep while driving a car. You see 30% relates to like drinking habits. And the objective, this is one of the problems that we try to solve. Is it possible to give a warning 15 minutes before somebody is falling asleep, or at last 5 minutes after the first microsleep? A microsleep is when you feel, I must be careful because I might fall asleep. There is in a modern car over 300 sensors or micromotors. There is 54 patents, but there is not a working system today. And the reason is it's a totally different individual problem. You do it every time in a different way. It's a time variable problem. That is that if you look to the system which needs to be developed, it needs to adapt continuously to what you do. And that is the key of the expertise of Byrix or the lab. We make real-time individual models of what you do. So if you would wear this sensor, I could see when you would fall asleep during this small talk. That would be nice to do as an experiment. There is many variables measured in a car. The Mercedes system that tries to measure concentration is measuring 72 variables in the car. There is not a single solution that is measuring what we call bioresponses, measuring something on your body, like heart rate or body temperatures. As I said, the real problem is that you all are complex. Ask your partner whether you are a complex system. You are individually different. A population solution doesn't work. It's a time-varying system. You need to adapt continuously, and it's dynamic. And that is what Byrix and the lab is doing. How can you solve that? By measuring continuously, by making a model continuously, and then using that information to manage the problem. M3 Byrix means measure, model, manage bioresponses. Byrix is bioresponses in complex systems. This is the objective, and it's one example. Don't be scared. It's a very simple thing. It's just an equation that runs, because you don't have to worry about it. But how it works is just estimating parameters in an equation. And when the A's and the B's are varying, that means something is varying in what you do. And in this case, we measure body temperature, heart rate, how you use the steering wheel and the pedals, and then we can see, okay, this person is falling asleep. For 20 years, the group is busy with this thing. This is just one example. Another example is what we do, condition monitoring for top athletes. We worked 3 years with Ancelotti on the AC Milan players. That comes to the world market end of this year by Adidas, who brings it in a shirt where everything is in the shirt. The sensors, the microprocessor, it's all there, and it measures the physical condition of what you can bring. The scheme is just showing that it's the variation of parameters that is doing the job. I would think 20 seconds is gone for this slide, no? Okay, but what normal modelers do, okay, I can talk about this slide too. So what we normally do is, you see, the type of work, what you need is quite extensive. We did over 650 experiments with 220 test subjects, people, that is through 3,500 hours of data. That's a huge amount of money. For Bosch, the German company in Stuttgart, that was 20 man-years to get the data together. We do only the algorithm, the software, the small piece of doing the calculation. This is the different steps we go through for this problem. So we test it on real subjects, more subjects now. We bring it to the real car. We have a car with sensors Where Byrix brings just the equation, Bosch will bring all the rest. That is a market partner that brings it to the market. At the same time, it's the technology partner that allows us to bring this abstract equation in a product. And the idea is that we finally come with a solution for sleepiness monitoring. Here you see the result, 24 subjects, 100% were correctly classified who fall asleep, 81 were correctly classified who did not fall asleep. So there we still have to improve something. The 0 is where the first microsleep is. The -20, that means 20 minutes before we could predict that that person would fall asleep. The best result is we can predict it 45 minutes before you fall asleep. But that is not what Bosch wants. What they want is, if you get the warning and you're not stopping the car, you will feel that it totally goes wrong in the next 5 minutes. You will believe that system. This is one example. Another example, how would we measure it? This is a test on like body temperatures that is integrated in the mirror of the car. Every time you drive, the mirror is just measuring with infrared sensor your body temperature. Another variable that we measure is like the fingertip temperature. That can be done by integrating a sensor in the steering wheel. The position of the steering wheel. We did some master theses to see how do people use the steering wheel to find out where do we need to put sensors? Do we need to put them everywhere or just in specific places? The assumption is at least one hand will hold the steering wheel. The tricky thing is that 3 years from now there will be no steering wheel. The first car who can do that job without comes next year to the market. You will see about that. Heart rate is measured in the seat. It's integrated in the driving seat. This is just one example, but condition monitoring, different mental states like fear or happiness, all these things can be measured in a similar way. There is different projects who are doing it. It's always the same thing. It's about what happens around you, your response to that, and how we use that in an equation that goes specifically for you. So it runs always in a fully automated way. The AC Milan players, every 4 minutes after starting the training, the model was made for each of them. Here you see a prototype, how it can look like. It's all integrated, the camera for the infrared measurement, the sensors, it's all in the steering wheel. As I told you, since the steering wheel will disappear, this will not be the solution that you will see. This is one of the ideas for the prototype to discuss with Bosch whether it's a realistic thing. Conclusion, we are all complex, individually different, time-varying, dynamic. For this problem, I think we can solve it, and we hope that we see it in the market by 2014. Bosch is now doing the experiments in the real car. It's just one of the examples that we try to solve. And if you're interested, you're welcome to see others.